So we were talking about the shear reinforcement. So let us go to the ETAB, and we have to go to the display and click on the shear reinforcement and apply. Right. So now you can see the shear reinforcement has been shown to you as inch square. Let us see that it will be inch square per foot. You can change the units from here, consistent units, and make it inches. So now you can see the reinforcement in inch square per inch. Right, you can verify it by right clicking on it and go to the summary. So now you can see that reinforcement has, for shear reinforcement, has been shown as 0.0195 inch square per inch. So now you have to select the maximum value from it, and it will be more easier if you keep it in feet, and then after selecting that we will change it into inch square per inch for the comparison purposes with the minimum reinforcement. Right, so we have to see for the maximum value of shear. Right, so you can see that there are three values shown on the screen, that is from the left, mid, and right. So it is asking you to provide this much shear reinforcement in this area region, this much in mid region, and this on the right region. Right, so you can make your structure economical by providing 0.3 inch square per foot up to here. How much is the length for the this much? That is 2h. If you have depth of 24 inch, so this length will be equal to 48 inches, and this will be 48 inches, and the remaining will be this 0.21 inch square per foot. So we will select the maximum value, that is right. So it is 0.32 for the support, 0.3, and the maximum at the mid is 0.2. It is 0.3 as well. So in here it is 0.2, 0.25, 0.25. Here is a 0.12. So we will select for the support. Near the support we will give 0.3, and at mid we will give 0.25, that is 0.1. We will go to another story. You can see there is slight differences in their shear demand due to the increase in the height. Right, so for the simplicity and to make your drawings and your design very simple, we will select the maximum value for the shear at the support is 0.3. At the support that is equal to 0.3 inch square per foot, and at mid we will have 0.25 inch square. Right, so let us convert this into inch so we can compare it with the minimum requirement of the ACI for the shear reinforcement. So we will convert this feet into inches. So we have to divide this 0.3 by 12. So it is come out to be 0.025 inch square per inch. And the next one is 0.25 divided by 12. It is 0.0208 inch square per foot. So now you have to select from these values whichever is the greater one. Here we have 0.08 inch square per inch, So this is the governing for the minimum, and we have this from ETAB. We have 0.05 inch square per inch. Inch square per inch. So this is less than the minimum requirement, and you can see that 0.0208 inch square per inch is for the mid, which is also less than the minimum requirement of the ACI. So this is governs in all the cases, right? From the ETABS, we will provide 0.08 inch square per inch in our beams. So how we do that? We will use number 3 bar, and we will divide this bar area by the area required, right? So we will do that in here. Let us do it here. 0.11 divided by 0.08. So it is one leg. So if I explain it in here, that this is the beam, right? And these are the strips, right? This is the strip. So this is one leg, and this is the two leg. So we have to divide it with the area of the two legs. So the area of one leg is 0.11, and if you are providing two legs, so it will be 0.22, right? So we have to provide number 3 bar with two legs at the rate 2.65 inches, which is very, very less. So either you have to increase the dia of the bar for the transverse reinforcement, or you have to increase the number of the legs. So normally the dia of the bar is not increased because it becomes very uneconomical. The number of the legs is increased, and we provide, for example, this is our beam, and this is the first strip, and this is the one bar. Example, this is provided 4 bars. So you have to provide, you can provide your legs like this. This is the first leg, and this is the another leg. There are different arrangements you can do it for your design, right? So in our case, we have selected 2 bars, 3 bars for the bottom, and 4 bars for the top, right? So these are our calculations. For the top we have 4 bars, and the bottom we have 6 bars. But now you can see that this arrangement will change with the requirement of the shear reinforcement, right? So you have to make it 4 bars at the bottom and 4 bars at the top, in order to provide 4 leg strips in your beam, in order to incorporate or fulfill the requirement of the code. So right, for example, you have to provide 4 legs, so you have to write 0.44. So now you have to provide 4 legs strips in your beam at the rate 5 inches center to center, right? So let us go and write in here a 0.44, which is equal to, you have to write 4 legs dash number 3 bar at the rate 5 inches center to center. You can also increase dia of the bar, so you can use only 2 legs. And how we do that? You have to insert the value of the 2 leg bars for number 4. The one area of one leg for number 4 is 0.2, and for the 2 is 0.4. So you have to provide it 4.5 inches center to center if you use number 4 bars. You can also get option that use 2 legs number 4 bar at the rate 4.5 inches center to center. So these are the two options. Whichever is feasible for you, you can select it, right? So this is the design for the share from ETAB, and we have done it manual calculation using the ETAB, the ACI code recommendations. Now the next part is the limits for the ACI limits for the maximum shear reinforced spacing for the beams that is specified in in table 9.7.2.2, and it says that this is the table, that if your VS is less than or equal to 4 under root FC prime BWD, this will be the limitation, and if it is greater than this, so this will be your limitation. So in our case, it is 571 kip. This value is come out to be 571 kips. So let us go to the ETAB and check for the VS, whether it is greater than from this or not. So you have to select one of the beam, and we will go to assembly, and we will check the VS value, right? So this is actually, the code is not using the phi, it is including the phi value. So the VS value in here is the 9.011, and we have calculated it is 571 kips. So it means it is greater than the VS value. This value is greater than VS, so we will be using this condition for our maximum spacing, and which is right, for example, 9.1 kips from the ETAB. So now the limit is that the maximum spacing for the beam should not be greater than this or this. So this is the pretest. So we have D by 4. So in our case, D is 21.75. So you have to divide it by 4. Its value will be this, and the another option is 12 inches, right? So let us divide 21.75 divided by 4. So its value is 5. So your value should not be greater than 5, right? So what we have provided is that we
Sir, excuse me sir, sir ये पहला वाला यूज नहीं करेंगे, ये वैल्यू तो उससे कम है, जो कैलकुलेटेड है इक्वेशन से वो तो ETAB वाले से ज्यादा है, तो हम ये पहला वाला ऑप्शन यूज करेंगे.
VS is less than, yes ये अगेन मैंने ये मेरे ख्याल मैंने कॉलम में भी इस तरह किया था. यस बिलाल, ये आपने कहा?
यस सर.
अच्छा, थैंक यू. ये एक्चुअली इस फर्स्ट वन है, क्योंकि VS हमारे पास 9 है, which is less than this value. So we will be using the first option. I have done this mistake previously in your column. Thanks for the correction, Bilal. So this VS is less than this capacity of the concrete. So we will be using this D by 2. In our case, D is 21.75 divided by 2. So it will be, and the second is 24 inches, right? So we will be using this. So this is 2. So the limit is 10 inches. So you do not have to provide the straight spacing greater than 10 inches. What we have provided is 5 inches. So we have fulfilled this requirement of ACI as well, right? So our value is 4.5 inches in case of the number 4 bar, and in number 3 bar we have 5 inches, right? So up to maximum 10 inches you can go, right? So this was the limitation for the shear reinforcement for the beam, right? So this was the whole story about the design of the beam. Let us go towards the design of the structure walls. That the ACI 318.14 limits for the minimum reinforcement for the wall is defined in table 11.6.1. that you have to provide at least minimum reinforcement this much if the tape is not showing any reinforcement. So normally it governs at 0.0025. So this is the wall, it is cost in place, so it is pre-cost. So you have to select your value, and there is a defined bars and its size. If you are using the size less than or equal to 5, number 5 bars, and there is a limit on FC prime if you are using 60,000 or less than 60,000. So if you are in our case, we will be using number 4 bars. So the value is 60,000 FY, and the minimum longitudinal reinforcement is 0.0012, and the minimum transfer is 0.002, right? So these are the minimum reinforcement. But normally, if you use greater bars, so the value is changing correspondingly, right? So let us go to the ETAB, because ETAB automatically calculates the minimum ratio, minimum reinforcement for you, and we'll compare it with these. So for the share, I have already run the analysis, right? So this is our structure walls. So first of all, let us go to the retaining wall, right? So ETAB is showing you different two values for the walls, that is 35.28 and 35.28. These are not the top and bottom reinforcement. It is showing you the station. That at the top station, this much value is required, and the bottom station, this much value is required. You can verify it by right clicking on the wall. Right. So this report has been shown to you that this is the pair label, and this is the centroid. This is the length, because we have assigned single pair to the whole wall, and this is the thickness, and these are the different material values, properties, design parameters, and FC prime FY, right? So this is the pair design, which is the uh, pair location of the wall in its thicknesses and length. And this is the flexure design for the retaining wall. This is the station. You can see top and bottom is not the top and bottom reinforcements. These are the station location, top and bottom. This is the required rebar area is 35.28, and this is the required reinforcement ratio is 0.0025, 0.0025, right? So the design combo is automatically selected by the ETAB is 0.99D plus FY, right? So the ETAB is automatically selected. This value is 0.0025 and 0.0025 for the transverse, and it is also considered as 0.0025 for the longitudinal as well. There is another, I think I have, right. So this is the first case, right? This is case one, when the shear demand is less than the half shear capacity of the concrete. So you have to manually calculate this F5VC divided by 2 if it's greater than VU. So you have to use this table, right? The second case is that when the shear demand is greater than the half shear capacity of the concrete, so you have to use this value is 0.0025. So let us go to the ETAB and see 5VC. So in here we have this 5VC is 2134, right? And we have this VU is this is 507 kip, right? So we have to calculate this value manually, and you have to compare with the minimum requirement, which table you have to use. So ETABS automatically do this analysis for you and select the required reinforcement ratio for your wall, and it is selected 0.0025, 0.0025 for the flexure, right? So these are the two conditions. If you are doing your analysis manually, so you have to perform this check whether it's the shear capacity of concrete is half shear capacity of concrete is greater than the demand. So you have to select the value from here. And if this shear capacity is half shear capacity is less than the demand, shear demand, so you have to select this value 0.0025. So software automatically do this check for you, and it is selected 0.0025 for the flexure reinforcement. And for the shear, it is given as 0.35 inch square per foot. So you want to confirm it whether it is correct or not for the reinforcement ratio, whether it is selected 0.0025 or not. You can verify it by using this value 0.0025. So write 0.0025. So this is the ratio, and the thickness of this wall is 12 inches. So you have to multiply with 12. So let me do it. So this is the 12. Please give me 1 second. All right. So this is the summary of the shear wall, right? So that if you multiply this ratio 0.0025 with this thickness and this length and divided by the length in feet by 12, so you will get the minimum reinforcement that is taken as 0.3 0.36 inch square per foot for the shear, right? So this is the very simple check. You can also do it, because we have to further design our systems. So this limits is for both flexure and shear reinforcement. This is 0.0025, and ETABS do it for you. And then we will go for the design. And this is the another check for the boundary element check. I think most of the students are not familiar with it. For example, if there are different stresses that exceeding the ACI limits, software will ask you about the boundary element. If it is written in here not needed, it means there is no need for the boundary element. Boundary element is actually a column. You have to provide extra flexure member, which is known as a column, for the support for the column for the walls. So if there is no need of the boundary elements, you do not have to provide any extra columns. But if it is asking you that you have to provide boundary element, so then you have to provide extra column. Then you have to again interact with the architect that I am giving a column, extra column in here for the retaining wall or shear wall, whatever it is, right? So for the flexure, it is giving me the total reinforcement in inch square, that is 35.28 inch square, and this is the length. So you have to divide this length area by the length, so you can get the inch square per running length, and then you can find out the spacing from it, right? So for the longitudinal, we have total value of reinforcement is 35.28 inch square, right? And the total length is 1176 inches. So you have to divide this value by 1176 inches. So you will get the reinforcement in inch square per inch. So let us do that. That is 35.28 divided by 1176. It is 0.03 inch square per inch, right? So if I multiply it with 12, let me do that. So the another check has been performed, that is 0.36 inch square per foot. So you can also see that the shear demand that has been, shear reinforcement that has been given is 0.36. So this is how you calculate, verify whether it is the 0.0025 ratio has been used or not, right? So we are getting 0.36 inch square per foot for the flexure, and for the shear we are also getting 0.36 inch square per foot. Both are the same because ETAB has used for this reinforcement ratio 0.0025 for both the demands. So now you can find out the spacing from it by dividing this bar. For example, if you are using number 4 bar, so divide this 0.36 and multiply it with 12. So 0.2 divided by this with 12. So this come out to be 6.6 inches. We will go for the 6 inches, right? So we will go use number 4 bar at the rate 6 inches center to center. You can also use number 3 bar, but the spacing will reduce, and you have to keep in mind the concreting in all of these while selecting the bar size. So this is same for the flexure and shear. So this is our final design for the retaining wall, that is number 4 at the rate 6 inches center to center for flexure and for the shear, right? So this is the minimum reinforcement given by the ETAB, and this is the minimum reinforcement according to the ECI code. Now the next one is the shear walls. So select one of the shear wall because all of the shear wall have the same properties. So let us click in here. Again, it is showing you two values, that is top station and bottom station. These are not top and bottom reinforcements. These are the different stations. So now you can see the length of this panel is 180 inches and the thickness is 12 inches. And the flexure design is this 5.4 inch square, right? And again, the minimum reinforcement for the shear is 0.3. You can also verify this 5.4 inches. How did the ETAB calculated this value? You have to multiply this ratio 0.0025 with the total length and thickness of this wall. Let us do that. That is 0.0025 into the thickness is 12 and the length is 180. So you have to multiply with 180. It comes out to be 5.4. So this is how you calculate or verify the values from the ETAB. So ETAB is also giving us the flexure reinforcement is 5.4 inches, and we previously we verified this, and now we have verified this value from the minimum reinforcement of the ACI code. Right, so let us go in here and write this 5.4 inch square, and we will divide it with the length, which is 180 inches, and it comes out to be again 0.3 inch square per inch, right? And for the shear it is 0.3 square per inch. And if the ETAB value is greater than the minimum, so we have to provide that value accordingly. So again, we will use number 4 bar at the rate 6 inches center to center because we have performed this exercise previously. And again, number 4 bar at the rate 6 inches center to center. Now the last one is for the structure wall is the lift walls. And I will show you if you want to see any failure in these walls, how do you see that? So we have assigned same pair to the left wall as well. So this is the benefit if you assign same pair to different panels or one shear walls. So it will be easy for you to calculate reinforcement in one wall and then apply for the to the all walls. So let us click on this left wall and see the design for the flexion and shear. So again, you can see the length has been taken as a total length because we have assigned only one pair to the left walls, and the thickness is 15 inches and the length is 432. So let us go to the design, and again it is taken as 0.025 as the minimum value for the shear ratio, flexure shear flexure reinforcement ratio, and the required value is now is different, right? At the top station it is 19.8 and the bottom station it is 17.55. So you have to go for the higher value. You will select 19.8, right? And this is the design combination, right? And this is the shear design, right? It is asking you 0.45. Now it is different from what we get from the retaining wall and for the shear walls. So now you have to write the longitudinal reinforcement as 19.8. So let us make it 20. This is 20 inch square and we have to divide it with the length. So we will get in inch square per inch. And the length is 432 inches. This is 432 inches and we will get this value. And we are getting 0.45 inch square. Perfect. So now let us do these calculations. So we have this, this is 20 inch square and we will divide it with 432. So we are getting 0.046 inch square per inch. If we use number 4 bars, so 0.2 divided by this, we are getting 4.32 inches 100%, which is a very feasible spacing between these bars, because if you increase the bar size, it will give you more spacing, which will become, if you use number 6 bar, it is point, so it is giving you 9.5 inches. So whether you have to use this number 4 bar at the rate 4 inches or number 6 bar at the rate of 9 inches. So this is your choice. So the next one is for the shear. It is 0.45 inch square per foot. So we have to divide this value. You are using number 2 bar divided by 0.45 and multiply with 12. So we will get the value for the shear. So it's come out to be 4 or 5 inches center to center if you use number 4 bars, right? So we have two options in here. You use number 4 bar at the rate 4 inches center to center. So these are, I'm talking about for only one layer, right? You are providing only one layer in your retaining walls or lift walls or shear walls. If you are using 2 layers, then you have to divide these required reinforcement by 2, right? So if we in retaining wall we have used only one layer, this is in one layer, this is this shear wall, shear reinforcement and the shear reinforcement in one layer, right? So if you are using 2 layers, you can divide this area by 2, spacing by 2. So how we do it, let me show you. Include this, and you can use, please turn off your mic, please. Use number 6 bar at the rate 9 inches center, right? And for the yeah, mic ban kiya, cha mic on the right. So for number for shear, we have, you have to use number 4 bar at the rate 5 inches center to center, right? So this is the design for the structure walls. So I was talking about these are for the one layer, right? All of these are for the one layer. So if you are willing to use two layers, then you have to divide the required area by 2 or increase the spacing by 2.
सर
जी
सर ये आप लोगों ने लॉन्ग और शेयर लिखे, ये लॉन्ग और शॉर्ट है या लॉन्ग और शेयर है?
ये लॉन्गिट्यूडनल रेनफोर्समेंट है,
लॉन्गिट्यूडनल रिइंफोर्समेंट, ठीक है जी, ओके
फ्लेक्सुरल
सर। और ये
रेनफोर्समेंट
शेयर
ऑफ the
रिइंफोर्समेंट, ठीक है सर, ठीक है सर,
right?
ओके क्लियर।
Right, if you are using two layers, so you have to provide this. For example, if you go for number 4, so you have to use number 4 at the rate 12 inches center to center layer, right? Same for the this one, because these are the same in each layer. This is for the 2 layers and this is for the 1 layer, and same is in here. You have to provide in 2 layers, so you have to multiply the spacing by 2 or divide divide this area by 2. You will get the same result. And for this you have to go number 6 at the rate 9 inch center to center. But if you use this, you have to go for the 18 inches, which is again out of the range for the serviceability issues and for the crack of the concrete. So you have to go for this. So for the second layer, you can use number 4 at the rate 8 inches in each layer, and in here you can use in each layer. So if you are using 1 layer, you have to go for this, and if you are using 2 layers, you have to go for this, and same for all of these structure walls.
Excuse me, sir, layer means mesh?
Yes, meshing, I'm talking about the mesh. Let me show it in here. For example, this is your wall, and if you are providing only 1 layer, this is the shear reinforcement, this is the flexure. And if you are providing only this 1 layer, so you have to go for this calculations. If you are providing 2 layers, for example, this is 1 layer, and you are providing also, let me draw it in here. For example, this is the wall, and you are providing 2 layers. So this is the first layer, and this is the second layer. If you are providing the reinforcement in 2 layers, so then you have to accordingly divide the required area by 2 or multiply the required spacing by 2. Right, so you will see in the drafting, when I finalize the drafting, I will show you all of these. What does it mean? Right, so this is the 2 layer shear walls or retaining walls, and this is the 1 layer, right? So this is how you do that. So this was the whole story about the structure walls and how you check the minimum reinforcements and get values from the ETAB. Now we will go towards the maximum spacing of these walls, etc., and for the design of slab. And let me stop this recording and share me the new link for the part 3.